Today in this question we are going to do the estimation of the RCC frame structure, and here we have the plan in this portion, and here we have two rooms having the size of 3.5 into 3.5. We have the columns in this portion, this portion, this portion and these portions. So we have 6 number of the column in this question, and we have the section of the column in this portion, and we have the section of this wall in this side. And today we are going to calculate the following items: earthwork in excavation in the foundation, stone soling in the foundation, PCC for RCC, brickwork up to the plinth, and sand filling in the floor. So we have this type of this footing in our column, whereas in the wall portion we have this type of the section. So the actual 3D view of our foundation will look like this. So here we can see that there are the columns having this type of the footing. So the first step is to calculate this earthwork in excavation in the foundation for the column. So we need to see the plan. So here we can see that there are 6 number of these columns, and these columns are of width of 1 meter, and we need to do the excavation up to the ground level. So this is our ground level portion, and we have this total height of 1.5 meter up to the ground level. We need to do the excavation of 1 meter width. So the number is 6, and we have the width of 1 meter and the length is also 1 meter, since it is a square column, and its height is 1.5 meter up to the ground level. So we have done the excavation of this 1 meter width of this column. Now we need to do the excavation for the wall section. So our first step is to calculate the total center line between these two columns. So we have this distance of 3.5 meter, and we have the column of size 0.3 meter. That means this total center to center distance is equals to 3.5 plus 0.3 by 2, and again 0.3 by 2, that is equals to 3.8 meter. Here also we will get 3.8 meter, but from this center to this center we will get the total center line of total 4.1 minus 0.3 by 2, and again minus 0.3 by 2, that is equals to 3.8 meter. Now we have already done the excavation for the column having the width of 1 meter and length of 1 meter. So now we need to consider these walls, this wall, this wall and this wall. So these walls are along x direction, and we will consider this walls along the y direction in separate topics. So firstly, this wall along the x direction. So here we have already calculated the total center line distance as 3.8 meter, but now we need to calculate the length from this side up to this side only. That is, in this center line of 3.8 meter we need to deduct this portion, that is half of this excavation width, that is 1 by 2, and again here also we have this width of 1 meter, and we need to deduct this small portion, that is we need to deduct 2 number of 1 by 2, that is this portion and this portion. And we have these 4 number of the wall along the x direction having the width of 0.45 meter. That is, for the walls along the x direction we have the number equals to 4, and its length is equals to center line length, that is 3.8 meter. We need to deduct the half of the foundation width of the column, that are 2 in number. So we will get 2.8 meter. So the length equals to 2.8 meter, and the width is equals to this 0.45. That is, this is the section for the wall, so our width equals to 0.45. So this height of the excavation is equals to this portion plus this portion plus this portion, because this is our ground level, and this total height is equals to 0.35 plus this portion is 0.1 meter, and this portion is 0.15 meter. So this total height is equals to 0.6 meter. So height is 0.6 meter. Now we need to do the excavation for the wall along the y direction. So in this y direction we have the 3 number of the walls having the width of 0.45, and we have already calculated the total center to center distance, that is 3.8 meter. That is, in this center line length we need to deduct this portion, that is half of the width of this column, that is 1 by 2 from one side, and again deduct this 1 by 2 from this side to get this portion length. Numbers are 3 having the length of center line length 3.8 minus we need to deduct the 2 number of the column having the width of 1 by 2. So its length is equals to 2.8 meter, and it also has a width of 0.45, and the height is also same, that is 0.6 meter. Now we need to calculate the stone soling in the foundation, and always remember that we calculate the stone soling in meter square. So we don't write the height in the stone soling. So we have the stone soling in this portion, that is in 1 meter width. The columns numbers are same, that is 6 in number, and its length and breadth is same as above. That is the length of this column and the width is 1 meter. So our next step is to calculate the stone soling in the foundation for the wall along the x and y direction, and for this we need to see our section. So here our stone soling is kept in this portion, that is here we can see it is 15 centimeter stone soling. So this total height is equals to 1.2 meter from this plinth beam, that is 0.3 plus 0.3 plus 0.35 plus this small portion is 0.1 and this portion is 0.15 meter. So this height equals to 1.2 meter, and at this same level, that is at the same height of 1.2 meter in this column, we will see that it has a width of 0.3 meter because this height is equals to 1.3 meter and 1.2 meter will lie somewhere over here. So in this level it will have the width of 0.3 meter column. So our plan will look like this, that is in this column it will have 0.3 meter, whereas in this portion we will have 0.45 meter width. So our plan will look like this, and here we are going to calculate the x direction beam, that is this portion, this portion, this portion and this portion. So we have 4 number of these beams in x direction having the width of 0.45. So 4 number of the beam having the width of 0.45, but we need to calculate the length. So here we have this center to center distance as 3.8 meter, and we need to deduct this half portion, that is 0.3/2 from one side and another 0.3 from one side. So our length is equals to 3.8 meter minus 2 number of the column having the width of 0.3/2, that is equals to 3.5 meter. So length is 3.5 and we don't need to write its height. Now we need to calculate the beam along the y direction. So here we have the 3 number of these beams along the y directions having the width of 0.45. So the number is 3 and width is 0.45, and we need to calculate its length. So here also the length will be the center to center distance, that is 3.8 minus 0.3/2 from this side and again minus 0.3 from this side. So the length will be equals to center line length 3.8 minus 2 into 0.3/2, that is equals to 3.5 meter, and no need to write its height. So here we have done the soling in this portion, this portion, this portion and all these portions. But here we can see that this small portion is considered twice while doing the soling on this side as well as on this side. So we can see that the number of overlapped portion is 1, 2, 3, 4, 5, 6, 7 and 8. So the number of overlapped portions are 8, so they should be deducted, and this length of this overlap portion is equals to 0.45 minus 0.3/2, that is equals to 0.075 from this side, and this width is also 0.075. So deduction is to be made, and number of deductions are 8 in number, and the length is equals to 0.075, that is 0.45 minus 0.3 meter wall by 2, and its width is also same, and no need to write its height. Now we need to do the PCC for these columns and the wall. So we have 6 number of the column. PCC is done in this portion having the height of 0.1 meter and the width is 1 meter. So length and the breadth is 1 meter and its height is 0.1 meter. Now we need to calculate the walls along the x direction. So here PCC is kept over this small portion having the height of 0.1 meter. So it means that our height from this portion up to this portion is 1.05 meter from this plinth beam, and at the same time we have this 1.05 meter somewhere over this portion, because this portion is 1.3 meter and 1.05 will lie somewhere over this portion. So it means that for this column portion we have the width of 0.3 meter, whereas our wall section will have the width of 0.45 meter. So our plan will be same as the soling portion, that is we will need to deduct all these 8 number of these projections having the width of 0.075, and all the length and the breadth will also be the same, only the height will be different. So our length and the breadth will be same as this, so we can simply copy all these number and length and breadth, only the difference will be the height. So we have these PCC having the height of 0.1 meter, so height is 0.1 for both these, and we need to deduct 8 number of this overlapped portion having the length of 0.075 and width also 0.075 and the height of 0.1 meter. Our next step is to calculate this PCC for the RCC up to the plinth beam. So here this is the section of the column, and we have this PCC for RCC in this portion. That is, here in this portion there is the reinforcement, and we do the PCC for this RCC portions. So this portion is our plinth beam portion, that is 0.3 meter into 0.3 meter. That is, we need to do the PCC for RCC for all these portions. So firstly, here we have this as our rectangular portion, so we will consider this as our rectangular portion, and above this there is a sloped portion, so we will consider this portion as our slope portion. So I have considered this as a rectangular portion for this column. So firstly, we have these columns 6 in number, and it has a length of 0.9 meter. Here we can see it is 0.9 meter. That means since it is our square column, we have the length and breadth of 0.9 meter. So length is also 0.9 and the breadth is also 0.9, and it has a height of 0.25 meter. So height equals to 0.25 meter. And next is our slope portion. That is, we are considering this portion up to this portion. So this portion is our slope portion. So here we can see that at the base it has the length and breadth of 0.9 meter, whereas at its top it has length and breadth of 0.3 meter. I will consider the A1 for this bottom portion, that is 0.9 into 0.9. So simply the area for the bottom portion equals to 0.9 into 0.9, that is equals to 0.81. Similarly, I will consider the A2, that is the area for the upper portion. So at the upper portion we have the area of 0.3 into 0.3, since this portion is 0.3 meter. So this area is equals to 0.09. Now for this area I will take the average of A1 and A2. So I'll write this area equals to 0.81 plus 0.09 divided by 2, since it is a slope portion. Now we need to calculate its height, because volume equals to area into height. So its height is equals to 0.3 meter, that is the slope portion height. So simply into 0.3. And we have the slope portion, that is our column are 6 in number, so it also has a number of 6, and we can easily calculate its quantity. Now I will consider the above the slope portion and below the plinth beam. So it means that we are considering the portion from this side up to this side, that is above our slope portion and below the plinth beam. This is our plinth beam, and we are going to consider this portion. So here it has a width of 0.3 meter. Since it is a square column, the length and the breadth is equals to 0.3 meter, and we need to calculate its height. So here we have this total portion 0.3 and this portion is 1.5, and we need to deduct this portion, that is 0.15, and this portion is 0.1, and this portion has a height of 0.25, and this portion has a height of 0.3. So we will get this total height from this side up to this side as 0.7 meter, but we need the total height from this side up to this side. So this portion has a height of 0.3 and this portion has a height of 0.7. So this total height is equals to 0.7 plus 0.3, that is equals to 1 meter. So firstly, its height is equals to 1 meter, and we have these 6 in number, and this portion has a width and length of 0.3 meter since it is a square column. So length is also 0.3 and width is also 0.3 meter. Now we need to calculate this plinth beam portion, that is this small portion. Small portion has a length of 0.3, width is also 0.3, and this height is also 0.3 meter. And there are 6 number of the column, so the number is equals to 6. Number is 6, length is also 0.3, width is also 0.3, and height is also 0.3 meter. Our next step is to calculate this brickwork up to the plinth for the wall section, that is. So now we are going to do the brickwork in this portion, and it has a width of 0.35 meter, and its height is equals to 0.35 plus 0.3, that is equals to 0.65 meter. So below the plinth beam we have the width of 0.35 in this wall section, and similarly below this plinth beam we have the width of 0.3 meter for this column portion. So our plan will look like this, that is our column will be the width of 0.3 meter, whereas our beam portion will have the width of 0.35 meter. We don't need to do the brickwork for these column portions because we have already done the PCC for the RCC in this portion. So we are going to do the brickwork for this X and the Y directions beam. So firstly we are going to do this X direction beam. So we have already calculated the total center to center distance as 3.8 meter, and here we need to deduct this half portion, that is 0.3/2 from one side and another 0.3/2 from another side. So along the X direction we have 4 number of these beams, that is here 2 and here 2, and the length is equals to center distance, that is 3.8 meter, minus we need to deduct the 2 number of the column having the width of 0.3/2. So we get 3.5 meter, and its width is 0.35 and its height is equals to 0.65. Now we need to calculate the brickwork for the beam along the Y directions. So in our Y direction we have these 3 number of these beams. So number is 3 and its length is equals to center to center distance, that is 3.8 meter, and here also we need to deduct the 2 number of these beams having the width of 0.3/2. So length will be equals to 3.5 meter and its width is same as above, that is 0.35, and height is also 0.65. So now we need to do the deduction portions. So we have 8 number of these portions that should be deducted. So number equals to 8, and now we need to calculate the length and breadth of the deductions. So we have this width of 0.35 in this brickwork portion, whereas we have this width of 0.3 in the column at this level. So we need to calculate the length of this overlap portion. So this length is, we have this width of this beam 0.35 meter, whereas in the column portion we have the width of 0.3 meter. So this small portion will be obviously 0.35 minus 0.3 divided by 2. So this portion is equals to 0.025. So 0.025, and the width is also 0.025, and the height is same as above, that is 0.65 meter, and we need to deduct this portion. So here we have done the brickwork in this portion. Now we need to do the brickwork in this small plinth beam portion. So in this portion we have the width of 0.3, whereas in this portion of the plinth beam of the column we have also the width of 0.3, that is both are the width of 0.3 meter. So its plan will be same as this given plan, because this is also 0.3 and this portion is also 0.3 meter. So here we can see that there is no any overlapped portion, and we can easily calculate the length of this portion. So this length is already given, that is equals to 3.5 meter, and it has a width of 0.3 meter. And here in X direction we have these beams 4 in number. So for the plinth beam in X direction we have the number equals to 4, and the length is equals to 3.5 meter, and the width is 0.3 meter, and it has a height of 0.3 meter. Similarly in the Y direction we have these 3 number of these beams. So number equals to 3, and its length is equals to this inner to inner portion, because we don't do the brickwork for this portions. So its length is equals to outer length 4.1 minus 2 times of this 0.3. So the length equals to 3.5 meter, and its width is also 0.3, and the height is also 0.3. So our last step is to calculate this sand filling on the floor, and for this we need to see the section, because our sand filling is kept in this inner portions, and firstly we need to see the section between these two portions. So when we see the section on this side, then we will get the section of the wall on this side, and here also we will get the section of the wall. That is, we will get this type of this section on both sides of the room. So here I have made this type of this section on both sides of this room. So this portion is our plinth beam having the width of 0.3 and 0.3 height. So this is our plinth beam having the width and the height of 0.3 on both sides. Similarly, I have made this portion, that is width of 0.35 on this portion, and it has a height of 0.3 plus 0.35. So I need to make this portion on this inner side. That is, this portion is our 10 centimeter PCC that is given here. The next is our 15 centimeter stone soling, that is 0.15 meter stone soling on this side. And now we can see we need to do this sand filling of 30 centimeter height. So this is our sand filling having the height of 0.3 meter, and here we can see that this is our sand filling portion, but here we can see that it lies on this part as well as this part. We have this inner dimension of this room as 3.5 meter. That is, this inner portion of this room is 3.5 meter. But in this section we can see that our sand filling is kept only in this portion. But when we make this sand filling portion with actual height, then it will lie on this portion as well as on this portion. So firstly, sand filling for this upper portion. So we have this sand filling for upper portion 1 in number, and its length will be the length from this side up to this side. So we already have this length, that is, this length is 3.5 meter inner dimension of this room. So the length is 3.5 meter, and to calculate the width we need to see the section from this side. That is, while looking at the section from this side, here also we will get the section of this wall portion, and here also we will get the section of the wall, and we have this inner dimension 3.5 meter. So here also we will get this same type of the section. That is, here also the section of this wall, and here also the section of this wall. And we need to do the sand filling on this portion. The width is also 3.5 meter. So I'll write the width as 3.5 meter. Now we need to consider the height. So here we can see that we have this height of 0.3 meter plinth beam, and we have this width 10 centimeter PCC, that is 0.1, and this height is 0.15 meter stone soling. That is, this small portion height will be 0.3 minus 0.1 minus 0.15, that is equals to 0.05 meter. So this portion height is 0.05 meter. So I can write the height equals to 0.3 meter plinth beam minus 0.1 meter PCC minus 0.15 soling. So the height is equals to 0.05 meter. So height equals to 0.05 meter. Now we need to do the sand filling for this lower portion. That is, we are going to consider this portion. So it means that we need to consider the length only from this side up to this side. So the length will be equals to, this is 3.5 meter, and we need to deduct this portion from this side and this portion from this side. So this small portion length will be equals to, this is equals to 0.35 brickwork portion, and this is 0.3 meter. So this portion will be obviously 0.35 minus 0.3 by 2, that is equals to 0.025. So I will consider the length equals to inner dimension of this room 3.5 meter minus this projection of 0.025. So 0.025 into 2, that is equals to 3.45 meter. So the number equals to 1, and this length is 3.45, and now we need to calculate its width. So we will have this same type of the section, that is, the length will be equals to its breadth. So I will simply write the breadth equals to 3.45, and its height is to be calculated. So we need the height from this portion up to this portion only. So we have this total portion 0.3 meter, that is 30 centimeter sand filling, and we have already done this portion, that is 0.05 is already considered. So this height is equals to 0.3 minus 0.05. So I will write the height equals to our sand filling portion 0.3 minus this portion that is already considered minus 0.05. So we get 0.25 meter height. So height equals to 0.25. So now we have already done the sand filling in this portion of this room. Now we need to do the sand filling in this room. So all the number, length and breadth will be same as before. So for this second room, we can easily copy all these number, length, breadth and height for this sand filling portion, and we can easily calculate all the quantities. So in this way we have done the estimation of this RCC frame structure. So if you like my video, please do like, share and subscribe.